I was discussing about Reinfellow counting method. There what we observed that for arbitrary types of load signal or stress signals, how to extract the reversals or you can say cycles that we observe. So, in today's lecture we will discuss about this Reinfellow method that we can say. Here we will discuss about cumulative fatigue damage and Palmgren-Minard's rule in details. So, this is the content of today's lecture. Here first of all I will discuss about Minard's rule, then I will discuss about examples of Palmgren-Minard's rule, and finally what are the references I followed for this lecture, that details I will discuss. So, what we can observe then, in certain application the mechanical component is subjected to different stress level for different part of its working cycle, that we can say. So, the life of such a component generally is determined with the help of Palmgren-Minard's rule, or simply we can say Minard's equation. So, what is Minard's equation, that related details now I am going to discuss. Suppose a mechanical component which is subjected to a completely reverse stress cycle sigma 1. So, let us consider a mechanical component, I am writing a component subjected to completely reverse stresses of different amplitude, that means it can be reverse stresses or fluctuating stresses, whatever reversed stresses, that will be better to understand. Okay. So, let us consider that different stress level are sigma 1 stress for n1 number of cycle, sigma 2 stresses, sigma 2 stress for n2 number of cycle, and similarly these types of different stress level, and finally let us consider sigma x stress for nx number of cycle. So, if a structural component is subjected to different stress level for different number of what it is called cycle, then for this different cycle actually how the what it is called damage of this structure, or you can say cumulative effect of these different stresses on that structure we can calculate. That thing generally was invented by a scientist whose name is Minard's. That is why what happens, with the help of this Minard's equation we can find out what is the fatigue cumulative damage due to different stress level, that I am going to discuss. So, in this structure, if only sigma 1 stress, if only sigma stress apply, then let N1 be the capital N1 be the number of stress cycles before fatigue failure, Okay. This you should keep. So, if only sigma 1 stress applied, then let N1 be the number of stress cycle before fatigue failure. That means, it is its overall you can say fatigue alive if only sigma 1 stress is acting. Now, if only sigma 2 stress applied in this component, then let n to be the number of stress cycle before fatigue failure. What I am telling, understand? So, from here what we can do, we can get a very interesting information. That means, you know, if one types of reversal stress cycle, if it is subjected, then what happens, whatever the what it is called fatigue life of that component, that we can easily find out. Similarly, here if only one types of stress sigma 1, if it is acting, then what happens, let us consider n1 is its fatigue life. Fatigue life means, that means it can sustain n1 number of cycle before failure. If sigma 2 act, then let us consider capital N2 is the maximum number of stress cycle it can subjected to before failure. Sigma 1 stress level, what we can write, some arithmetic calculation we can do here. So, we can write that n1 number of cycles, you can say, is equal to the full fatigue life or total fatigue life. That means, if you write it in proportionate way, then you can say n1 number of cycle equivalent to, you can say, full or 1 proportion of fatigue life. So, for this sigma 1 stress, n number of cycle equivalent to what? N number of cycle equivalent to what we can write? 1 by n1, you can say, proportionate of fatigue life of fatigue life, or you can say fatigue damage, that will be better. Fatigue proportionate of. So, what we observe that here initially I have written this sigma 1 stress level, it is generally subjected to n1 number of cycle. So, n1 number of cycle whose stress magnitude is sigma 1 stress, that means sigma 1 stress is subjected to n1 small n1 number of cycles. So, this small n1 number of cycle, how much what is called fatigue damage it will consume, or how much proportionate of you can say fatigue life it will consume, that we can easily find out from this what is called arithmetic calculation, that you can say. So, n1 number of cycles will consume how much proportionate of fatigue life, small n1 by capital N1 proportionate of fatigue damage, that we can say. Okay. So, similarly what we can write, the proportionate damage due to a stress level sigma 2 will be. So, similarly for sigma 2 stress level, where n2 number of cycle it is subjected to. So, you see for this case where n2 number of cycles is subjected to, initially I have written already. So, here what we can write, similarly for sigma 2 stress level, the proportionate damage will be what? Will be similar arithmetic calculation, if you just do, will be equal to, you can say, n2 by capital N2, what I have already written. So, similar way what we can write, if there are different number of stress level and it is subjected to different number of stress cycle also, then what happens? For this case, this way we can easily find out what are the different proportionate damage will be for different stress level, that we can easily find out. For that, instead let us consider for you can say sigma s stress level, where the stress cycle is. So, here the number of cycle is we consider is let us n x. So, here for the sigma s x stress level, the you can say proportionate damage will be, we can say n x by capital N x, correct. This we can write. So, let us consider this is equation number 1, equation number 2 let us consider this is equation number x number of equation. So, if we just add all this equation n 1 by capital N 1 plus n 2 by capital N 2 plus n x by capital N x. So, before let us consider before fatigue failure, n x number of stress cycle it is subjected to for a stress level of sigma x. So, this way if we just add it, this should be equal to actually full proportion of fatigue damage. Full proportion of fatigue damage means 1 full. So, that is why this n 1 by n 1 plus n 2 by n 2, this should be equal to 1. So, this is generally called cumulative fatigue damage. So, cumulative fatigue damage means with the adding of different stress level of different stress cycle, how much proportion of damage is taken place before failure, that we can easily calculate. So, what happen if it is less than 1, then we can say it can subjected to some further stress level and further number of cycle. If it is equal to or greater than equal to 1, so it will fail, you can say, that means it will damage fully. What I am telling, understand? So, this equation, let us consider this is equation number 4. This equation number 4 was established by the researcher whose name is Miners. That is why this equation number 4 is called Miners equation. What it is called? Miners equation. This we should keep it in mind. Okay. So, what is Miners equation? You got the idea. Now, some cases generally instead of different stress level, different number of cycle, some cases generally what happens, instead of number of cycle there it is provided, that means a particular stress level is subjected to a particular proportion of time, total time of that component. What I am telling, understand? So, sometimes generally this number of cycle n 1 n 2 at a stress level sigma 1 sigma 2 is unknown. What I am telling, understand? So, what we can say, like what happens, let us in a breeze per day, let us consider there is going some proportion, sometime what is called scooter, sometime buses, sometimes some private cars, sometimes some lorry. So, what happens, these different you can say vehicle have different stress level. So, for that what happens, and what happens, how much proportion of that different vehicles is going per day, that proportionate time if it is given, based on that things also we can establish a relationship. How it is, that also we can say. So, sometimes the number of cycle if it is, let us what happens, sometimes what can be the things n 1, n 2 or n x, if let us this is this n 1 n 2, if n 1 n 2 is unknown for sigma 1, sigma 2, sigma n stress level. For this case, let us consider alpha 1, alpha 2, alpha x are the proportion of total life that will be consumed by the stress level. For that case, let us consider, suppose alpha 1 alpha 2 alpha x are the proportion of proportions of the total fatigue life. Let us this total fatigue life is capital N. So, for that case, suppose alpha 1 alpha 2 are the proportionate of the total fatigue light which will be consumed here I am writing, which will be consumed by sigma 1 sigma 2 sigma x stress level, you can say for that case. So, here one thing you should keep it is this N is the total fatigue life, which is actually this equal to your N1 plus N2 plus N3 plus Nx. These are the things you should keep it in mind. Okay. This is the total number of cycle subjected to different stress level. If you just that add all this cycle together, then whatever the cycle it will be, that is the total number of cycle, that is let us consider N, capital N. So, that with respect to this capital N, let us consider alpha 1 proportion of time is consumed by sigma 1 stress, alpha 2 proportion of time is consumed by what it is called sigma 2 stress, and similarly let us alpha x proportion of the, you can say, total life N will be consumed by sigma x. So, for this case what we can write, so what is alpha 1? So, for this case what we need to find out? We need to find out small n 1 small n 2 in terms of this proportionate life alpha 1. So, alpha 1 actually what? Alpha 1 is, you can say, let us consider. So, here n 1 by n. So, here n 1 is the, I am considering, let us consider, because this is unknown, this n 1 is here is unknown. So, I am assuming, let us consider alpha 1 proportionate of total life is consumed by n 1 number of cycle. What I am telling, sir, understand. So, similarly what we can write, alpha 2 equal to let us this n 2 by capital N, and you can say alpha x we can write as n x by capital N. This you should keep it in mind. So, from here what happens, in terms of this proportionate time we can calculate what is a small n 1. So, a small n 1 you can write as total life of this component capital N into alpha 1. Similarly, you can write from this alpha 2, we can write n 2 is equal to alpha 2 into capital N, and you can say n x we can write as alpha x into n, correct. Now, these are the information what we need to do. Now, what is Minard's equation? Already I have shown Minard's equation, I have already shown that n 1 by capital N 1 small n 2 by capital N 2 plus n x by capital N x, this equal to 1. So, this is from equation 4, from equation number 4. This we know, this is Minard's equation, I have already told you how it is coming. If here, if we put this n 1 value in terms of what it is called proportionate time or proportionate life of that different stress level. So, n 1 equal to, I have already told you this n 1 equal to alpha 1 into capital N divided by n 1, n 2 is equal to alpha 2 into capital N divided by n 2 plus plus alpha x into capital N. Capital N is the total life cycle of that component, that is fatigue life cycle, and n x due to the effect of all different stress level. This you should keep it in mind. So, by this what we can write, alpha 1 by n 1 plus alpha 2 by n 2 plus dot alpha x by n x, this we can write as 1 by capital N. This you should keep it in mind. So, with the help of these things what we can do, if a body is subjected to different proportion of time of different stress level, then what happen, by this we can easily find out what is the total life cycle n of that mechanical component. What I am telling, understand, of that component. Here one things you should keep it in mind. Here I have already told you, that means if you just add alpha 1 plus alpha 2 plus alpha x, this proportionate also should be equal to 1. How it is coming? Little bit I am showing, because this is n 1 by capital N plus n 2 by capital N plus dot what is called n x by capital N, this equal to 1. How it is coming this equal to 1, thus I am just showing, this is 1, here top side will be n 1 plus n 2 plus n x. So, you see this equal to top side also it is coming n 1 n 2, I have already told you this equal to your total number of cycles. So, n by n, this equal to, you can say, equal to 1. This you should keep it in mind. So, by this generally what happens, if a component with is subjected to what it is called different stress level for different number of cycle, then what should be total fatigue life, that we can calculate. That we can calculate with the help of equation number 5. And if a component is subjected to different cycle with different stress level, for that what should be its cumulative fatigue damage, that means how much proportion of the damage it is subjected to. If it is less than 1, then what happens, we can say this structure is safe. If it is greater than equal to 1, then what happens, this structure is not safe. These are the things you should keep it in mind. Okay. So, that is why here I have written this total cumulative fatigue damage, you can say this total cumulative fatigue damage is due to different number of cycle, and due to different this Ni by this capital Ni, summation of these things we can write as summation of di. That means Ni by capital Ni equal to, you can say, di. This you can say. That means for a particular stress level, if it is subjected to a small Ni number of cycle, and for that stress level, if the fatigue life of this component using SN curve is capital Ni, then the ratio of these things is called di, that is the fatigue damage due to that particular stress level sigma I. This you should keep it in mind. So, what happens if the body is subjected to different these stresses, that is sigma 1, sigma 2, I have already told you. For that case you can write n 1 by capital N 1 plus n 2 by capital N 2 plus let us n x by capital N x. If this is greater than equal to 1, then what happens, this body will be subjected to fatigue failure. That means it crosses its damage limit. What I am telling, understand. If it is less than 1, then what happens, it can further subjected to some further stress level and further number of cycle. These are the things only here it is given. So, this damage condition was proposed by these two researchers, you can say, one is called Palmgren and Miners. Based on this name, this is this equation also called Palmgren Miners rule or Palmgren's Miner equations. Okay. So, these are the things only here it is given. So, now we will solve one problem on example first based on this Palmgren Miners rule, After that we will solve some practical problems, one what it is called this using this Minard's rule, what are the different steps followed there, find out the overall fatigue life of that component, that related things we will discuss. Okay. So, some example of Palmgren's Minard rule. So, for Palmgren-Minard's rule, what are the things generally required? First of all, for Palmgren-Minard's rule we need, that means time stress signal, that we need. So, that is why here I have written, first we need time signal, that is time versus stress signal we know, that means with time how the stress is varying and what is the number of that cycle, that also required to know. After that time signal we have to tally with SN curve. With the SN curve generally and this time signal, what we need to do? We need to find out what it is called damage factor. How it is? Because based on this time signal, whatever the amplitude of this stress level, based on this stress level with the help of this SN curve, we can find out what is the what is called fatigue life for this stress level Ni. Let us what happen, it is subjected to a stress level sigma I and it is subjected to a stress number of cycle is let us Ni. So, corresponding to this sigma I amplitude, by using SN curves we can easily find out what is the fatigue life for that particular stress level. So, we can find out from the SN curve this capital Ni. So, in time signal or stress versus time signal, here we will be providing Ni and stress magnitude. Based on this stress magnitude, we need to find out this capital Ni, what it is called, with the help of SN curve, this you should keep it in mind. So, now Ni and capital Ni is known, now we need to tally the damage. How? That damage is D equal to, you can say Di equal to, you can say small Ni divided by capital Ni. So, you see this small Ni generally we can find out from the time versus stress signal of that component. So, one two example or simple example I am just showing, then it will be very clear to you. So, let us consider here generally this SN curve, if you consider in log plot, this stress strain curve also generally depending upon these things, generally from stress strain curve also this number of cycle also you need to put in terms of log form, this you should keep it in mind. Okay. If you just put the things in stress strain curve number of cycle in normal way, then this SN curve also should be in normal way. What I am telling, understand? So, how it is one to problem, simple problem, if we will just do, then it will be very clear to you. So, let us consider an example. It is subjected to a uniform amplitude. This is one example I am showing. It is subjected to a uniform reverse types of, you can say fully reverse types of stress cycle. This is cycle number 1 and this is cycle number 2. It is subjected to 2 number of cycle. So, in SN curve let us consider here it is not in log form, let us consider in capital form. So, corresponding to this stress magnitude, you see stress magnitude, we need to find out what is the capital N1. So, this is number of cycle is N1 is equal to, here is 2, here stress amplitude is, let us consider sigma 1. So, corresponding to this sigma 1, we can easily find out by SN curve what is the number of cycle capital N1, that we can easily find out. That I have already shown in previous lecture itself, using SN curve how to find out fatigue life. If fatigue life is given, then how to find out its fatigue stress, that we can easily find out. So, if only this sigma 1 is applied in this structure, then what should be this fatigue life? So, from this generally SN curve, let us consider it is based on this SN curve we calculate this capital N1 value, that is equal to let us 6. Now, what is the damage value here? So, the damage value will be generally this small n1 by capital N1. So, small n1 is given as 2 number of cycle and capital N1 is given as 6 number of cycle. So, here the damage value is 0.33, which is much lesser than what it is called 1. So, that is why what happens this, so here 1/3 of the life of the part has been used. So, we can use further number of cycle, that means this structure can subjected to more number of cycle, that means its 2/3 of the life is remain. So, that we can easily find out based on this what is called Palmgren-Minard's rule, you can say equation or Palmgren-Minard's rule concept. Okay. So, how it is you got the idea. Okay. Now, another problem let us consider with this sigma 1, this N1, let us consider we add another little bit higher stress level. So, for that component let us another 2 higher stress level we apply. Let us consider this higher stress level sigma 2, if this sigma 2 we use, then what happens, it can sustain, that means here for this sigma 2 let us consider your fatigue life is a capital N2. That means, it can subjected to capital N2 equal to your 4 number of cycle. So, here we use what you can say this 2 number of this sigma 2 cycle. So, here sigma 2 stress level we use N2 equal to 2. So, here due to this sigma 2 what should be the fatigue damage, if the number of cycle is small N2 equal to 2. So, here fatigue damage due to stress level 2 will be equal to, you can say small n2 divided by capital N2 equal to, you can write as 2 divided by 4, that will be equal to, you can write as 0.5.